type expressions. So, for all programming language constructs and the programming language program elements, so we will have some types. So, we can understand that when we have got some variables, so they have got a type. When we are talking about some say expression, the expressions have got some type. But what can happen is that these constructs, programming language constructs, so they will also have some type. For example, some statement also can have a type. A typical example may be the statement may be taken as correct or syntactically correct or syntactically incorrect, or maybe syntactically it is correct, but in the expression in the when you go to these components of it, there is some type error. So, for the whole construct, so we can say that there is a type error. So, that when we are pointing out some type mismatch, so we can tell that at such and such statement, so there is a type error. So, they are used for type expressions, they are used to represent types of language constructs. A type expression can be basic type like integer, real, character, boolean, other atomic types. Atomic type means they cannot be divided further. So, like an integer type, so you cannot divide it into further until and unless say if we say that okay, there is a bit type, and based on that bit the integer is framed based on the bit. So, if that is the case, then that so in that case integer also can become a derived type, particularly if you are looking into the hardware description languages. So, there we have got these bits as the basic type, and from there we can construct integers of different bit widths. So, similarly, this real, character, boolean, so they are all atomic types and they do not have further internal structure. So, they are the atomic type, and there is a special type called type error. So, for indicating type violation. So, whenever there is a type violation, so associated with the corresponding with the construct, so we will put that its type is of type error. So, that we can point out the type errors. Then we can have a type name, that is we can define a new type and give it a name, and we can have some type constructors. So, we will see that like array is a constructor, then your record is a constructor. So, how can we construct types from the basic types? So, that will be the constructed thing. So, we will look into some examples of these constructed types. First of all, the arrays. So, array is a constructed type, like say array I t, where t is a type, it may be a basic type or may be a constructed type or derived type, and I is an integer or a range of integers. Like say in C declaration we have got say this int a 100. So, in this int a 100, so it identifies the an array A to be of size to be of type 100 integer. So, in as I said that okay, it can be a range of integers also. For this is particularly true in some other programming languages, like C language you will not find it, particularly hardware description languages. So, we have got this type of constructs, like you can define an array A and you can tell the range. So, 1 was a 1 dot dot 20. So, it is saying that the lines, the indices will run from 1 to 20. So, that way it is not uncommon, it is not impossible to have say minus 5 dot dot say 10. So, this is also an array. So, we have got the indices will run from minus 5 to 10. So, these are all possible, like this range, that is why it is said to be a range. So, in this case the range is obvious. So, it is 0 to 99. Okay. It is 0 to 99, but in some cases so it is not so obvious. So, like here it is you have to be more explicit, like minus 5 to 10. So, whereas here the range is implicit in nature. So, that is one type of constructor, that is collection of a basic collection of some already defined type. So, elements of that type. Then we can have some records, like say T 1 and T 2, if they are two type expression, then T 1 cross T 2 represents anonymous records. So, if you have got any variable or symbol of that particular type T 1 dot T 2. So, like say u is a variable whose type is say T 1 cross T 2. that will mean that I will in u there will be two components, one is u1 and another is u2. Okay. So, there will be u1 and u2, where this u1 will be of type T1 and u2 will be of type T2. So, this is of type T1 and u2 is of type T2. So, that way we can have some record type. So, this is very close, like if I have got say one argument as integer and another argument as real, when you are calling a function, when you are passing parameters, then this argument list passed to a function with first argument integer and second real, it will have the type integer cross real. So, that way we can have this type expression. So, this is unnamed because or anonymous record because it does not have a name. So, sometimes we associate some name also with the this type of type. Okay. This so, in this case, so if we have a name, like for example, the structure construct in C language. So, where you have got the structures, they have got some name. So, that name will get associated with the type. So, apart from that, so we have got say named records. So, that previously we have seen unnamed records. So, we can have named records. So, these are products of products with named elements. So, for a record structure with two named fields, length and word, where length is an integer and word is an array of 10 characters, then the record type is its type is record and it is length cross integer. So, that gives the names of the individual fields of the record, and then their corresponding types are mentioned, the word and array 10 character. So, that way the length is of type word and integer is an array of 10 characters. So, it has got so, these are so this length is length is of type integer and word is an array of character 10. So, here this length has got the first field has got the name length, second field has the got name word, and also their corresponding types are mentioned. So, this is one type of named record that can, for which you can have type expression. Then if T is a type expression, then pointer T so is also a type expression. So, representing objects that are pointers to the objects of type T. So, this is quite common, like in almost all the programming languages that supports pointers, we will have some way to specify this. So, here also, so as a compiler designer, so we have to support this pointer type, and this pointer T is a type expression, and it will represent objects of pointers to objects of type T. And in case of function, it maps a collection of types to one collection of types to another. So, it is a D to R, where D is the domain and R is the range of the function. So, we can have something like this, like if I have got a function say integer f1, and it has got arguments like say integer x and real y, integer x and real y. So, here the domain that we have is basically this the arguments, they are belonging to this cross type integer and real. So, this is integer cross real, and then that is the D actually. So, the integer cross real. So, this represents the D and the result is of type integer. So, this int. So, this is that R. So, R is the range of the function. So, domain of the function means the sets from which the function can get inputs, and range of the function means the set to which the function can produce output. So, we can have this type of function mapping. Okay. So, for that also, so this function f1 is of type this will map collection of types to another and represented by D to R. So, next we will see how this how this integer to cross integer to character. So, this is a function, this is an example of a function. that takes two integers as arguments and returns a character value. So, as I was telling in the previous example that f1, so it was integer cross real to integer. So, here it is integer cross integer to character. So, it takes two integers as arguments and returns a character value. Then we can have type expression integer to real to character. So, this is basically some sort of function pointer, so that returns a function. So, many programming languages support this type of constructs, like you can a function, it can return not only some basic value or these derived types, but it can also return another function as the return value. So, that that function will be called when that particular function will be called based on that. So, this integer to real to character. So, this function takes integer as an integer value as an argument, it takes the integer value as an argument, and as a return type it returns this real to character type. So, as this thing as you can understand that if this is that domain, so it takes values from D and this whole thing is the range. So, it maps this D to R, but what is this R? This R is again real to character. So, this is again a function. So, this is also for this function the domain is real and range is character. So, it is mapping from D to R. So, that way you can say that this return type is also a function. So, from domain D integer, so it is returning a function which can take a real argument and return a character value as the answer. So, this way we can have these function pointers also associate with that certain types. Okay. So, type system. So, this is it is a collection of rules for any programming language manual. If you look into, it will tell you like what are the rules of that particular language, type rules of that particular language. So, this type system of a language is the collection of rules that depicts a type expression assignment to program objects, like what are the how are these objects are assigned, what would be the type rules. So, they will be collected in the type system, and it is usually done with a syntax directed definition. So, it is done with syntax directed definition means that you can have this type check and all, and they will be implemented by means of this syntax directed translation scheme, because syntax directed translation scheme. So, it will the parse tree that is generated by the parser, it will have these individual symbols. So, you can get for the individual symbols their basic types, and those types are being converted into some derived type again by some grammar rules. So, that while those grammar rules are applied, so you can check whether the corresponding type is constructed properly or not, and if it is not, then it will be a type error. Otherwise, we can derive the type of the newly constructed portions. And type checker, this is an implementation of a type system. So, we have got type system that is specified by the language, and type checker is implemented by the compiler designer. So, type checker it will be using the syntax directed translation mechanism, and then it will be accordingly it will be producing some actions while doing the reductions in the programming language, in the grammar rules, while doing in the parser while it is doing the reductions. So, it can check for those rules of the language. Now, if you look into the languages, they can broadly be divided into two classes. So, one class is called strongly typed language, where all the variables that you have, all the functions, all the identifiers that you have in the program. So, their types are well defined. So, either they are explicitly defined or they are implicitly defined. So, why do I say so? Like in most of the languages like say C, so they are for every variable you have to have a corresponding definition, whereas certain programming language like for example Fortran, where the first character, if it is a vowel, in that case it will mean that this is going to be an integer. So, that way there are differences, but whatever it is, there are some implicit rules and there may be some explicit definitions. So, this compiler can verify that the program will execute without any type errors. So, while doing the parsing, the entire program is known. So, it is looking into the entire program, and if the compiler does not give any type error, then it is guaranteed that during execution of the program there will not be any type error. So, these checks are made statically. So, they are static checks, and they are also called a sound type system, because this type system, the type checker that we have, that is very rigorous in nature. So, they are called a sound type system. Completely eliminates the necessity of dynamic type checking, because there is nothing like no scope is left for this dynamic checking. So, it will eliminate the necessity of this dynamic type checking, and most programming languages are weakly typed. So, why it is so? Because many times it is not possible to have everything done statically. For example, this array bounds check, okay. Then so we cannot have those things that they to be done statically. So, most programming languages, they are weakly typed, and because this strongly typed language, they will put lot of restrictions on the programmers, like whenever you are defining a function. So, you should have its type specified, even for the language say C. So, if you define a function and do not if the function definition comes later. So, if you have a program where at this point I have defined the function say f1, so if I have defined the function f1 at this point, and then so here we have got the function f1, and somewhere earlier I am writing the code for I am calling the function f1, say x equal to f1, something like this. Then at this point of time the compiler has not seen the type of f1. So, it becomes difficult, because what is the type of f1. So, whether this statement is correct from the type point of view, that will depend on the interpretation of f1. But in C language, you know that it implicitly assumes that f1 is of type integer. So, that way so this does not put this requirement that f1 has to be defined previously and things like that. So, this type of flexibilities may be there. As a result, we can have this weakly typed construct. So, weakly typed thing. So, it will make the life of the programmer easy, but at the same time it also gives rise to the problem that the program may generate some error while executing in actual. So, strongly typed languages, they have got put lot of restrictions, and there are cases in which a type error can be caught dynamically only. As I was telling that say some array bound increasing beyond the limit. So, those type of checks cannot be done statically. So, they have to be done dynamically only. And similarly, when you are say calling say function pointer, so when it is returning a function, so whether that function is of proper type or not, so that can be checked only dynamically, because it will be decided at that point only whether the function that has been returned is returning a proper value. Okay. It is returning a proper value of correct type for assignment to some other variable. So, that way it can be checked dynamically only. And many languages will allow users to override the system, like this type overriding, like type coercion and all, where you can have a type casting. Okay. So, for example, C language, so that allows this type casting type of facility. So, it can allow you to override the system, the type system. So, these are some of the concerns for the strongly typed language, which we not only it may not be followed very rigorously because of these problems. Now, how do we do type checking for expressions? As I was telling that it will be using some syntax directed translation mechanism for doing this type check. So, this so it is so we assume that with the non terminals and terminals, so we will have some type. Okay. So, there is an attribute type which will be used for representing the type of an expression E. So, this E producing ID, So, this E dot type the corresponding action. So, when this particular reduction will be done. So, what we do in the symbol table we look up for this ID dot entry. So, it will be finding the entry in the symbol table, and once it finds it, so the corresponding type is also known. So, this expression's type is made equal to type of that particular entry. Then we if we have got a rule reduction like this, E producing E1 operator E2. So, this operator may be any arithmetic or logic operator. Okay. So, this E1 op E2. So, this E dot type is so if E1 dot type and E2 dot type are same, then it is E1 dot type, else it is type error. Now, this gives rise to many issues, like we are so it is expecting that the type of these two operands of this particular operator, they are same. Of course, we have not checked whether this particular operator is applicable on these operands or not. So, that check can also be introduced. So, if we do all those things, then so if for example, if I am talking about say addition and this E1 E2 they appear to be say string variable, then this addition does not have any meaning in them. So, though E1 dot type and E2 dot type both are string. So, we so in that case also the type of E should be type error. Of course, it is not captured in the rule that we have specified here. So, here it is simply checking that types of E1 and E2, and if their types are same, then it is said to be equal to E's type is said to be equal to E1 dot type, otherwise it is said to be a type error. Similarly, E1 relational operator E2. So, say some x greater than y, this type of expressions. So, here also this E1 dot type and E2 dot type they must be same. However, if they are same, after this relational operation the return type will be a Boolean variable. So, then in that case it returns a Boolean, otherwise it is a type error. So, this way I can have this E1 dot type equal to E2 dot type, then it will have this Boolean type, otherwise it is a type error. Then this is for the array. So, if so E producing E1 within bracket E2. So, this E1 and E1 is supposed to be some name, it is supposed to be of type array, and this E2 is some index. Okay. So, then it is the rule that we have is if E2 dot type is integer. So, this is supposed to be an index. So, this must be its type must be an integer. So, if E2's type is integer and E1's type is array st. Okay. So, if E1's type is array st, so this is an array, and then s is the size and t is the type of individual elements in the array st declaration. Then this in that case t will be in that case this type of this E will be t, otherwise this is a type error. So, this way we can derive the types of array elements and in an expression. Then this is E1 pointer. So, if E equal to E1 pointer, so in that case E dot type is so it is assigned to be t if E1's type is a pointer to t. So, t is the basic element, and if it is E1's type is pointer to t, then E's type will be t, otherwise this is a type error. So, this is just a simple example of this type rules, but you can think about more rigorous rules as I was talking about. So, whether these operators are applicable, whether these arrays that we have, so they are giving rise to further indices or not. So, multidimensional arrays and all. So, they are not taken care of in this particular expression. Then for the statements, so I said in some previously that statements also can have some type. Okay. So, statements normally do not have any value, hence their type is void. However, so if there is a type error in some statement which is nested deep inside a block, a set of rules are needed, because if there is a type error inside a block, then there is no point trying to generate code for the remaining part of the program. So, that entire block can be marked that there is a type error. So, this is what is done, like say ID S producing ID equal to E. So, this ID type, if ID's type is equal to E type, E's type, in that case this type of S is void, otherwise it is a type error. So, if there is a type mismatch between ID and E, then there is a type error, and the type error is assigned to S. So, that at a higher level we can understand that there was a type error that has occurred with this statement. So, we can take some appropriate action. So, it may be aborting the code generation or whatever, but we can do that. Similarly, this one, so if E then S1, so this this S dot type, so if its type is equal to, if E dot type is Boolean, then it is S1 type, else type error. So, in this, so the many programming languages, they will require that this is type be Boolean. Some other language, so it may not require, so like for example, in C language it is E dot type need not be Boolean, it has to be some it may be any integer or real, any other type, but so here it is taken as E dot type is Boolean. Some other programming language, they will require that the expression in the if statement to be Boolean type. So, it will check that if E dot type is Boolean, then S type is equal to S1 type. So, if S1 type is void, then S type will also be void. If S1 type is a type error, then S type will also be a type error. But if it is not Boolean, in that case, so this S type is said to be equal to type error. Then this while statement, this is also similar. If E dot type equal to Boolean, then S1 dot type, else type error. So, here also it is same, and then this concatenation of statements S1 semicolon S2. So, occurrence of successive occurrence of two statements S1 and S2. So, if S1 type is void and S2 type is void, then type of S will also be void, otherwise type of S is type error. So, if there is an error in S1 or S2, then their types are not void. So, in that case it will be a type error. So, if type checking of functions. So, if we have got something like this, like E producing E1 within bracket E2. So, this is E1 is the it is a function call. So, E1 is expected to be some ID or so, and then this E2. So, this E2 is expected to be the parameters that we are passing. So, this is like E dot type is if E2 dot type equal to S, okay, and E dot type is E1 dot type is S to T. So, E2 dot type is S and E1 dot type should be from that domain, like if E2 is an integer and then this function for E1, it should, its domain should be integer, and if it is domain is same as E2's type, and then we have to look into the range of E1. So, range of E1 is the return value type of E1. So, that is T, since the function given is S to T. So, that is the return type of it, and then it will be, in that case the is type will be T, otherwise it will be a type error. So, in this way we can have type checking for functions noted. So, we can talk about type equivalency. Now, it is sometimes it is needed to check that whether two types S and T, they are same or not. So, we can answer this by deciding equivalency between the two types, and this equivalency, there can be two categories, one is called name equivalency, another is called structural equivalency. So, equivalency check is necessary because many times we need to derive for an expression like say if x equal to say y. Now, this x and y, they may be apparently of different types, but we want to see whether they are of some equivalent type or not. So, that way so this so if it is one type of equivalency like name equivalency, so it will find that if the names of the two types are different, then it is they are not name equivalent. So, in that case it is a type error, and in some cases, so we will look for further. So, we will look into the structural part of it, and then we will see that whether they are structurally equivalent or not, and if they are structurally equivalent, then we can say that the two types are equivalent. So, this type equivalency is very important because we can so many times for the programmers is, so they define different types and they use different constructs for defining the types, and then while combining them, while checking them in the later part of the program, we do not make the programmer constrained by the type definitions. So, if they are equivalent types, then it should be taken into consideration. So, that gives rise to this equivalency. So, we will see this equivalency rules how to do all these checks in the next class.